In this example, we're going to complete a rotation of a simple square around at a 90-degree angle anti-clockwise. So if we just want to have a look at the example, what we're going to complete with first of all, this is an example of rotations. We'll set up a simple polygon square and we're going to rotate that anti-clockwise through an angle of 90 degrees. The key learning points in this will be establishing the center of rotation and how that is obtained when we have a point A and we want that image to be rotated until it meets point A1. How we establish our center of rotation, which in this example will be 90 degrees. Okay, to begin with, we'll open up our Geogebra program. I have selected my axis and I've selected the grid bar also. So the first thing to do is we're going to just plot a simple square. For this I have already chosen my options and labeling. I've selected new points only and I'm in the perspectives of geometry. So perspectives and geometry, like so. I'm going to keep my grid on and I'm going to keep my axis on. So in this case I'll just draw a simple regular polygon. I'm just going to plot my points from A to B, like so. Four sides will be my square and my points are plotted from C and D as well. So we have A, B, C and D. New points plotted only. What I'm going to do now is I'm going to create a new point, which will be in our option here. New point, and I'm going to create this point just here. Okay, at 6 minus 2. I'm going to create a point. That there at the moment is E, so I'm going to rename that point. I want that point to be B1. So point B1. So literally this is my object, point B, and I'm going to set up my center of rotation between B and B1 at a 90-degree angle so that B is rotated perfectly around to position B1. Like so. So the first thing I will do is I will join a segment line between my 2 points, B and B1. I'm going to create this line and I'm going to give it a lime green color for distinction. So it'll be between B and B1. Escape off that. So that there is the line from B to B1. Now my center of rotation lies somewhere along the perpendicular bisector of this line. Okay, I will come at an angle from here and I come at an angle from here to meet my perpendicular bisector. So in order to do that, I'm just going to create, first of all, I'm going to create the midpoint of that line, E, but I'm going to change the document properties of that. I do not want to see it as large as that, so I'm going to reduce the size of my point, and also I'm not going to show the label as the point E. So this there, that lies somewhere along my perpendicular bisector will lie along here. So I'm just going to draw that in first of all. Again, I need to decide what type that is, so I'm just going to leave it as a dashed line. I'm going to put it in red, and I'll bring down the size of it also. My perpendicular bisector of that line runs straight through my midpoint of that line, as we can see. So I'm going to escape off that. Somewhere along this line, coming at an angle from B and B1, lies my center of rotation. In this example, we want to create a center of rotation at 90 degrees. In that example, so if we want a 90-degree angle out here, using the principle of triangulation, and we take that away from 180 degrees, we will be left with a further 90 degrees. And if we split that between our 2 angles, B and B1, then it's a 45-degree projection to meet a point here, which will leave us a 90-degree angle, and we have a 45-degree angle down here to point B1 as well. So to create that, if we just use an option, we want an angle with given size, and our angle wants to go from the center to B1. That angle we want at 45 degrees anti-clockwise. Click OK to that, we can see there's our 45 degrees, like so, and running through this point on to meet that line will be our center of rotation. So I'm going to construct just a light line. It will be a ray through 2 points. I'm going to use, again, I'll keep it in lime green for this color, and I'm going to go from a ray through this point up like so. Now we can see exactly at that point where this line touches our perpendicular bisector will be my center of rotation. I could alternatively go from through the center to B1 out another 45-degree angle, that will show it to us, but in this case I'm just going to plot my point here exactly at that point. I can give that point actually some greater emphasis and give it a larger point because that's my center of rotation. And I'm also going to rename this. So I'll name it center. So there's my point center. So I'll just join a further line, my segment between my center and point B1, and the line from B to my center like so. And we can see there the emphasis of that line. Okay, that there triangle that is formed for us a 45 degree, we'll have a 90 degree and a 45 degree. So I'm just going to gain the object properties of this point, I'm just going to go into that and I'm going to click fix the point because we do not want our center of rotation to move. So that is a fixed point. And just to verify that our angles are correct, I might measure between this point and this edge. Oh, wrong one. This angle, sorry. So from this edge to that point. And we can see that inside there, if I just move my B1 around, we have our 45 degree angle like so. And we can just double check, here's our 45 degrees. We can double check to make sure that this angle is correct. Obviously it must be a 90 degree angle, as we can see, like so. So that is going to give me my center of rotation at a 90 degree angle. I'm going to rotate those points around. How do we do that? Inside in our circle option, we can look at our circular arc with center between 2 points. And I'm going to set up my arc so that it is in dash line. It's going to be a purple color. So there's my center. That's my point B. I want to rotate B around and it touches exactly at B1 at an angle of 90 degrees. So this point is rotated about the center from B to B1. What we need to do then is we just need to do this same example for our remaining points A, C and D. So when we're drawing this technically, what we will do is we will join points. I'm going to use a segment. Our construction lines I'm just going to keep in grey, and I would join a line from C to my center of rotation, and then I would go perpendicular to that. In this case we want to go at a 90 degree angle from that also. So I'm just going to use a perpendicular line from C through my center of rotation and escape like so. You can just see the little trace of my line that I've shown there for my perpendicular line. Okay. What I want to do is I want to rotate that around onto that line to give me a point which will be C1. So if I was rotating that, I rotate an object around a point by an angle. So this is my object C. I want to rotate it around my point and I want to go at an angle of 90 degrees. And that rotates right around onto this same perpendicular line I had gotten from the line coming from C to the center, give me point C1. I can show that with the trace, which I could have done in reverse from my center to my point, rotate around, give me exactly that point. That line from C1 to the center to C is a 90 degree angle anti-clockwise. That is showing our completed rotations. So if I was to transfer then the line from C to B, that's my object, and I can rotate that about my center 90 degrees clockwise, giving me this exact point here. Okay, just in relation to this labeling, I'm just going to no new objects and no new points. Okay, so we'll just leave that labeling off for now. Okay, not to overcomplicate things. So we can just complete the rest of that. I want to rotate this line around my center 90 degrees. We could complete all our constructions. It's the same principle. $90, and finally we want the line from A to D through our center at 90 degrees, and we're left with the edge from A to B, which is this one, 90 degrees like so, giving us our points. I might just hide the labels on this just so it doesn't overcomplicate things. Okay, there's some. That would be our rotated square through a 90 degree center Okay, coming around. We might, just to complete the example, we shall show the trace of my object, rotate around my center, and we can project this like so. So in that case, you want to actually touch the center first. So the center to D, rotate that around, right around onto point D1, escape, and again the center to the point we reach, which is A, and bring that around, right around to point A1, and escape like so. And what we can see, our center is fixed, but again I could, like we've shown before, I could move my point A, B, C and D around. The principle will remain the exact same. From B to B1 is rotated at a 90-degree angle anti-clockwise. Even if I brought them around to a clockwise direction, we can still see our method and our triangulation is set up from B to B1. Center of rotation is outside of that, so we'll be rotating around an anti-clockwise direction, B to B1. We'll just bring that back to our starting position like so. And that is an example of locating a center of rotation and projecting our image around to its new position.